Okay, Math 1, let's take a look at task 1.8, where the learning targets are, I can create a recursive equation, okay, for arithmetic and geometric. So we've been doing the same learning targets, but now we're going to focus on this idea of recursive, okay? A recursive equation is an equation that shows the pattern. It's going to show the pattern, okay, how you get from one term to the next. Okay, recursive equations are always based on the previous term. Okay, previous means the one before. The one before, the term that comes right before. Okay, so a current term, okay, or the function is usually going to be called something like f of x. And then the previous term, okay, what comes right before f of x is always going to be f of x minus 1. Okay, that's how you write a previous term. Okay, I need you to go over here to this page. I'm going to go over here now, and we're going to work on writing recursive equations. Okay, and there's always two parts to this. Okay, the important part with recursive, okay, number one, okay, is the pattern. Is the pattern relating each term to the previous term. Okay, so with that, you're going to want to do something like this. F of x minus 1, previous term, okay, and then add 3. Or maybe it's previous term minus 7, okay, or maybe it's previous term times by 5, okay, or maybe it's a divide pattern, so you'd have to say times by 1/2, okay? So it's always previous, and then it's always the pattern. The pattern might be adding or subtracting if it is arithmetic, and then the pattern might be multiply or divide, of course, if it's geometric, okay? So that's the first step, figuring out the pattern. And the second part that you always have to make sure you include, okay, is the first term. Okay, you can't fill out a chart unless I get you started. Okay, take a look at this sequence right here. Okay, the recursive equation is always going to start like we did before. Okay, our y variable or our function name is f of x. Okay, so what you're going to do is study these numbers and you're going to say, how do I get the next term? I take the one before it and I add a 3. How do I get to the next term? I take the previous term and I add 3. Okay, so if I asked you to fill out one more box in this table, how would you get the next value? You would go to the 11 and you would add 3. Okay, so the recursive equation is going to be take the previous. So whenever you write f of x minus 1, that means previous. Okay. And for this problem, it's add 3. That's all you have to do for recursive equations. Recursive equations are sometimes called, okay, the pattern equations. Pattern equations show us how to keep making all the numbers in the table. Okay, except how do you make all these numbers? Okay, I have to tell you how this table started. So here's the beginning of the table. Okay, and this is always like the little guy that you have to have. So f of 0. The first input was 0, and then the output is a 5. Okay, so show us the pattern and tell us how the table started. This is the starting values in the table. Let's try again, okay? Let's take a look at this chart. I noticed that they're calling it f of x, okay? So for my equation, I'm going to call the equation f of x, okay? When it says recursive, that means uses the previous. So what's before f of x? Go back, x minus 1. Okay, so take the previous, and then let's study this table to see how the numbers are formed. The numbers are being divided by 2 each time, which we can't write in a function. So we'll say multiply by 1/2. Okay, so the recursive equation here is take the previous, and what does the table do? Multiplies by 1/2. So if it said find the next row here, I would take 25, I would multiply by 1/2, and I would get 12.5. So when x is 10, we get 12.5. Okay, so recursive is continuing the pattern. Oh, but hang on, you also have to state the starting number here. Okay, I have to give you something to start with. So what is the first input? F of 7, and the output was 100. I have to give you a number to start with that you can keep cutting in half. Okay? So here's a common mistake. Unlike explicit equations, okay, the starting value does not change how we write them. Remember how we had to carefully look to see if we had to bring the x value back to 7? We don't have to do that. We're just going to say that our first value happens to be 7 and then 100, okay? But our recursive equation is always the same. Okay, let's take a look at this one here. The cafeteria had free lunch tickets to give away. Okay, on week 3, the cafeteria had 35 tickets left, and it gave away 5 each week. Okay, so after a week went by, they gave away 5, which is minus 5, so now they only have 30. And then minus 5 makes 25. Okay, we would call the weeks W, and then the number of tickets, they're saying T of W. I like that, T of W. Write a recursive equation. It's super important, okay, that you look at the directions to see if they say explicit or recursive. Recursive, remember, is the pattern kind of equation that uses the previous term. You have to remember that, and then writing the equation is going to be pretty straightforward. Okay, so I'm going to call this equation T of W. Okay, how does this table work? You take the number before, which is called previous, and then you do something. Okay, previous is going to be T of, what's before W? W minus 1. Okay, now what's the pattern for this table? The pattern here, the common difference, is subtract 5. Okay, oh, so let's see. To fill out one more line of this table, I would take the previous, okay, go to 20, and I should subtract 5, and that should take me to this next value, which would be 15. So 7 would give us 15. Okay, the only downside to recursive is if I asked you, what happens on week 100? 100? How in the world are we going to get all the way to 100? Well, to fill out 100, I would have to know the answer at number 99, and then all I would do is subtract 5, except I don't know the value at 99. Okay, so it would take us a really long time to get all the way down there. That's a downside to recursive. Okay. Oh, hang on, we almost forgot. In order to get this table going, you have to get it started. So you take your starting values, T of 3. Okay, the very first one, at 3 weeks, there was 35 tickets. Okay, let's keep going here. Take a look at this one. YouTube begins with 17 subscribers, and each week it triples. Okay, so what kind of sequence do we have here? Okay, since it said triples, that means multiply by 3. Multiply by 3. Okay, to write a recursive equation, okay, there's 2 steps, right? Step 1 is to describe the pattern, and then step 2 is to always state the starting values. How did this pattern start? Okay, so to write the equation, they call this S of X. So they're calling this S of X. So the days is going to be called X after X days. Okay, we're going to say that you take the previous. How do you write previous? It's going to be S of X minus 1. Okay, now what's the pattern for this sequence? Times by 3. So I'm going to say times by 3. Okay? But you also have to say how this sequence started. So let's take the very first set of values here. What is S of 0? What was the starting number? 17. Okay, great job. Let's take a look at this one. Okay. We've got months and grams of elements. Okay, now they're telling us here, write a recursive equation, and they want it to be called f of x. Okay, so f of x equals, okay, step 1 is to write the pattern. So we always say previous, okay, and then something happens. So the previous for f of x is going to be x minus 1. Now let's go study the chart to see what happens here. Okay. It looks like the numbers are getting smaller. They're all getting divided by 3. Okay, how do you write divide by 3 in an equation? That's right, you multiply by 1/3. Okay, so it's a previous, and then you say the pattern. Oh, but wait a minute, aren't we supposed to write how this table started? Okay, so what was the very first entry here? F of 2 gives us 900. Okay, if I give you the starting one and I tell you the pattern, you can make the rest of the table. Okay, so recursive always goes with the word previous. Okay, goes with the word previous. Okay, and you also have to make sure that you figure out the pattern. Okay, let's go over here where they have some blanks. There's no stories. They just have some numbers. Okay, so we have 5 blanks. Generate the first 5 terms, starting with f of 1. Okay, so f of 1 means the first term. Okay, they're telling me the first term is 35, so I'm going to fill out the first term being 35. Okay. They have to give you a starting value, and then the common difference is minus 5. Okay, so what that means, to make the next term, we would have to subtract 5. That makes 30. And we would have to subtract 5, 25. Subtract 5, 20. Subtract 5, 15. Okay, this is recursive because you're using the previous one and you have the pattern. We've been kind of doing recursive and pattern since day 1, right? Okay. For the second one, the first term is 20, okay? They tell you the first term, just put it right there, right away. Put the first one down. Now, let's see if we can make the rest, okay, by using the pattern. Common ratio means that this pattern is geometric. What are we going to do with the 3 there? Yes, we're going to multiply by 3. Okay, so times by 3 makes 60. Times by 3 makes 180. 180, okay, multiplies by 3, and we're going to get 540. Okay, what's 540 times by 3 make? Yeah, 1,620. Okay, so these 2 examples right here are going to be called recursive. Okay, recursive means uses the previous and the pattern. Okay, now these examples here, okay, these are explicit. Explicit equations are what we've been doing. Okay, and this is you can plug in any value. Okay, so this is not recursive. Explicit means you plug in values. You plug in values to work with the equation. Okay, so how am I going to find the first term? They didn't tell me the first term. They told me an equation. Okay, so if you look up here, here's a hint. The first term is called f of 1. Okay, so the first number you're going to plug in is a 1. So let's take our equation, and the x is the input. I'm going to plug in the number 1. Okay, then we're going to have to calculate this. 3 times 1 plus 4 makes 7. So the first term is 7. Okay, explicit equations are actually a little bit more work because you have to plug numbers in. All right, now let's find the second one. I'm going to call the second one number 2. See how that works? 3. And what's the input? Some people actually write an X, then they erase X and they replace it with the number we're plugging in. 3 times 2 is 6 plus 4 makes a 10. Okay, if you need help calculating, make sure you ask in class. All right, now it's time to find number 3. So we'll plug in a 3. 3 times input plus 4. My input is 3. 3 times 3 is 9 plus 4 is 13. Okay, now that we've found 3 of them, okay, we could keep going. But what some people do, okay, is they notice a pattern. Okay, you can't just do it with 2 things, but now that you have 3 things, you might be able to notice, it seems like these values are being added by 3. Adding by 3. Maybe I'll just make the last 2 with this pattern. Okay, because recursive is kind of easy. 13 plus 3 is 16, plus 3 more makes 19. I think that f of 5 is 19. Okay, if you don't like doing that, you could have continued on here. Okay, if I did f of 5, I think I would have gotten 19. Let's see, 3. Okay, and the input value x is a 5. 15 plus 4 is 19, of course. So you can do it by plugging numbers in, or once you have enough, you can continue the pattern. Okay, but you can't do a pattern until you see at least 3 values. Okay, let's try this explicit equation. The first term right here, I'm going to do by plugging in a 1. So this equation says 4,096 times 1/4 to the power. And the n is the input. So I'm going to plug in a 1. Maybe I'll use my calculator for this one. 4,096 times 1 divided by 4 seems like an easy way to do the fraction. Okay. And we're going to raise it. We're going to put this to the power of 1. And the value is 1,024. So the first one is 1,024. Okay, but we're going to have to keep going with a couple more. Okay, so let's do this again. Let's plug in f of 2. So you take this equation and your input is going to be a 2. 4096 times 1/4 to the power of 2. Remember, when you have a calculator, okay, I'm going to go up using my arrow keys, go up and grab that one, and I'm simply going to change the input instead of a 1 to a 2. And the answer is 256. Let's try it again. F of 3. 4,096 times 1/4 to the 3rd power. Okay, let's do it the fast way. Let's go up, up. Let's grab that equation. And let's change our input from a 2 to a 3. And we get 64. Okay, so we keep going. Okay, or maybe you guys can study this a little bit. Do you know how these numbers are getting smaller? It's definitely geometric. Okay, so it's going to be divide, and it's going to be divide by 4. Divide by 4. That's why we see 1/4. So if you'd like, we can just take 64 and divide by 4 to make 16. And then we can divide by 4 to make a 4. Okay? You can continue the pattern once you have 3 values. Once you have 3 values. You can't have 2 values, right? What if I showed you the number 5 and then the number 10? Can you tell me the pattern here? Not really. I can't tell if it's multiply by 2 or is it add 5. Okay, if I told you this one was 15, Can you tell the pattern now? Yes, the pattern is plus 5. You need to have 3 values to determine a pattern. We need 3 values to determine a pattern. P-A-T-T-E-R-N. Okay, 3 values. All right, the last 2 are recursive. So recursive are going to be nice and easy. Okay, recursive tells you the pattern. What is this? This is previous, and this is the pattern. So the pattern here is subtract 8. So this must be an arithmetic sequence. Okay, and they told us a very important step. Okay, f of 1 is 200. Okay, what that is the starting one. They have to get you started. Okay, now how do we find the rest of them? We're going to use the pattern. The pattern is subtract 8. So we're going to do 200 minus 8, and we're going to get 192. And then we're going to subtract 8 again, and we're going to get 184. And then we'll subtract 8 again and get 176. Subtracting 8 again, and we'll get 168. Okay, so recursive equations give you the start, and you have to look in the equation for the pattern. Last one, recursive equation. Okay, it says f of n equals f of n minus 1. So that's the previous. So this equation says take the number before, and then this is the pattern. The pattern is multiply by 3. Okay, everybody, please multiply by 3. Multiply by 3. Wait a minute. How do I find these numbers? You gotta get me started. I've got nothing to multiply by 3. Oh, here's the starting one. Okay, f of 1 is a 5. So now we're going to go ahead and times by 3. Times by 3. 45 times 3 makes 135. And what's 135 times 3? That's right, 405. Great job, guys.